Alright guys, so today I'm going to go ahead and review your writing quadratics unit test review. I'm going to go over some of the answers for your test on Wednesday. So I just wanted you guys to be able to know what you got right and wrong from the unit test review. So the first two questions are asking you to convert into standard form. Number one is written in factored form. Now I'm going to show you, I know I have some of the answers already here, but I'll go ahead and show you the work for this one. So it's written in factored form already. You could do this a couple different ways, but I like to keep the -1 and then distribute this part first. So distribute these two factors first. So x times x is x squared, and then x times 2 is 2x, and then -7x, and then minus 14. X squared. I'm going to combine like terms right here. So that's -5x minus 14. And then I'll take the -1 and distribute it in to the three terms inside the parentheses. So you could put -1x squared or just -x squared plus 5x plus 14. And now it's written in standard form. Remember, standard form is from highest power down to lowest. It's ax squared plus bx plus c. So that's number one. Number two is really similar. It's in vertex form, and you'd be converting it into standard form, which is the same thing. So this one I'll just kind of show you guys what I did. So I took x minus 1 squared and rewrote it as 2, because that's what squared means, that there's two of them. So I did that part first. I distributed those two factors, which gave me this, and then I distributed the 10 inside. Oh wait, sorry. I combined like terms, and then I distributed the 10 inside. Don't forget this -1. It is on the outside, so don't distribute anything to it. Just kind of take care of that part at the very end. So whatever you get here, once you distribute and you know everything's combined, then do the -1. So 10 minus 1 is 9. So the answer should be 10x squared minus 20x plus 9. So that's number one and number two. For numbers 3 and 4, you're going to convert into vertex form. So I'll go ahead and do number 3 for you. So let me go ahead and write it down. Y equals x squared minus 14x plus 41. So remember that if you ever want to write something into vertex form, you need two things. You need a, so I'll write that right here. I need a, and I need the vertex. Well, a is easy because this is standard form, and standard form has an a term. It's ax squared. So a is technically imaginary 1, so the a is 1. But what I don't know is the vertex, so I'm going to need to find it. But remember that we learned there's a formula to find the x of the vertex. It's opposite b over 2a. So we're going to use that idea here. So we'll do the opposite of b, which is the opposite of -14, divided by 2 times a, which is just 14 over 2, which is 7. So I know that the x in my vertex is a 7. So if I know the x is a 7, let me plug 7 in for x here and here. So y equals, I'm going to have 7 squared minus 14 times 7 plus 41. So I'll do 7 squared is 49, and then -14 times 7, that's minus 98, and plus 41. So I like to chunk, but do this however you want. You guys could just put it in a calculator. But I would probably do 49 and 41 first, because I know the 1 here would give me 50, and then I just had to add 40. So that's 90 minus 98, which is -8. So there's my A and there's my vertex. And once I have those two things, I can write an equation in vertex form. So you gotta remember the format for vertex form. So let me just write the format here. So it's y equals a x. You just need to remember that it's always opposite h squared plus k. So that's the format for vertex. So let me go ahead and now write in the a and the vertex. So y equals, a is 1. You can write 1 there, you don't have to, it's up to you. And then x, so the opposite of x, or h technically, is -7, and then -8. So there's the equation. And that's the equation in vertex form. So number 4 on the review sheet was really similar. No. Well, you can. You could do a double conversion if you want, which means multiply it all out, change it to standard form, and then do vertex form. To me, that's a lot of work. This one right here, it is already set up in factored form. So if you looked at it, and if you just took the two factors, so remember what minus 4 would give me a 0 here, 4. And then what minus 2 would give me a 0 here, 2. So if you took those two answers and you found the average, which is technically the middle number, or if you want to find average, you just add them. So 4 plus 2 is 6, and then divide it by 2. And that would give you 3. And you're always going to divide it by 2. So you either find the middle or find the average, and that's your x of your vertex. So if you actually do this by the intercepts, it's much faster. So if that's the x of your vertex, then that's the x value you're going to plug in here. And, sorry, in here. Oh, it gets fuzzy on me. So if you see right here, this is where I plugged it in. And I got 2. So 3 minus 4 is -1. 3 minus 2 is 1. And then don't forget that there's still a -2 out here. So you're multiplying all those together and you get 2. So here's my A. And A is still right there on the outside. So that's the A when it's in factored form. And then here's the vertex. So since I have those two things, now I can write the equation in vertex form. And that's the equation right there. So you can do it by factored form, by the intercepts, which is how you should do it because it's set up that way. But if you don't feel comfortable with it, then you can do a double conversion, and then it'll look similar to problem number 3. But whatever you guys want to do is good with me. All right. Let's go ahead and do. I'm only gonna do one of each because there's 2 problems of each here. So I'm just gonna do 5 and 7. It says, given 2 points, write the quadratic equation in vertex form. It's important that you guys realize what form they're asking for, because if it's asking for me to write in vertex form, just remember that means you need to know what A is and you need to know what vertex is. That's the only way you can write it in vertex form. The good thing is I have the vertex. So for number 5, it's -5, 2. And that's great. That means I got half the information. All I need to figure out is what A is. So I'm going to already try to set up the equation. And that's what I have written on my paper right now. So it says y equals blank. That's where A is going to go. I don't know what A is yet. But since I know the vertex, I could write the rest. X plus 5 squared plus 2. So it looks like this. And then I was given another point, which was -3, -2. So you're almost done writing the equation. You just have to figure out what A is. So here's the idea. If you're given another point, remember a point is a coordinate, and so you're given an x and a y. So plug in those values right here for this x and for this y, and then solve for a here. So I'm going to take the -2 is y, and I'm going to plug that in for y, the -2. So -2 equals, now this is what I don't know, so I'm going to leave it as a, so I could solve for that variable. And then x is actually a -3. So -3, and then I'm going to leave everything else the same. So if I solve this or simplify this problem, I should be able to solve for a. So -2a, so I'm going to do -3 plus 5. That would be 2 squared plus 2. You guys have to kind of realize that these right here are all stuck together. This is one term. So be careful on your PEMDAS here. 2 squared is 4. And this would be a, I'll go ahead and write it, times 4 plus 2. Well, a times 4 is 4a, right? It's just like 5x. We would never write x5. You would always write the number first. So I'm going to go ahead and write the 4 first and then the a. And then I'm just going to solve this equation. So -2 minus 2. And then divide by 4 to get a by itself. So a is -1. So since I now know that a is -1, when I come back to this first step, you see how I just left the blank mark? Now I'm going to put a -1 right there. And then that's the equation. So that's for number 5. Number 6, very similar. The only difference is instead of another point, they gave you the y-intercept, which is really the same thing. You just need to rewrite it as a point. So let me write down some information. So our vertex now is at 4, 6, and the y-intercept is 22. So let me write the y-intercept 22 as a point. So if I had to write that as a point, the y-intercept is 22, so that means the y is at 22, and the x would be at 0. Remember, x is always 0 whenever you have a y-intercept. So now let me go to write the equation in vertex form. So y equals, I don't know what a is, but I do know what the vertex is, so I can write that part in. So it should look like that. So you almost have it all. You're just missing a. So remember that if you're given another point, that's your x and y. So I'm going to plug those values in for the x and y right here. And then I can solve for that a value. So y is 22 equals, this is a, which is what I'm trying to solve for. X is 0. So it should look like that. So 0 minus 4, that's -4. -4 squared, that's 16. And remember that these are together. So this is a times 16, which is 16 a's. Remember to rewrite it. You always want the number first and then the variable. And then I'll solve this. So this is 16. 16 is, and then divide by 16. And you have 1 equals a. So now that you know the a is 1, I can come back up here and just write in here, I could put a 1. And now I have the whole equation. So that's number 7. And number 8 is exactly the same thing. And number 6 is exactly like number 5. So I won't do those ones. I'll kind of let you guys do those ones. But yeah, 5 is just like 6 and 7 is just like 8. All right, if you look at 9 and 10, hopefully these ones were pretty easy. So it says, given the graph, write the quadratic in vertex form. So once again, remember that if you're going to ever write something in vertex form, you need a and you need vertex. So if we look at this graph, I definitely can see the vertexes right here. So the vertex is at 2, -5. And your job is to figure out what A is. So hopefully you guys remember how to find A. So A would be when you move over 1 unit, and it doesn't matter if it's to the left or to the right, what happens next? So when I move over 1 unit, I'll just go to the right. What happens next is that I go up 1. So that means A is up 1, which is +1. And there you go. I have everything I need. So I'll write y equals 1 x minus 2 squared minus 5. And that's the answer. Number 10. I'll go ahead and just do that one too, since these are pretty simple. There's the vertex. Remember, if we're writing in vertex form, we need A and we need vertex. So the vertex I can see is -5, 2. And then here, you have to be really careful when you go to find A. Like, really look. When you go over 1 unit, what's happening next? So look at the way the graph is labeled, because this is 1 and this is 2. When I go over 1, I go down half. So I don't go down all the way 1 unit, I go down half. So that means I go down half. So when I go to write the equation, it should look like this. And there's the answer. So hopefully those ones are okay. Oh wait, down half. Just kidding. Yeah, be careful with that A term. If it's going down, make sure you put the negative. All right, let's look at 11 and 12. Hopefully 11 and 12 are really easy too. So 11 and 12, it's saying given the transformation, write the quadratic in vertex form. So remember, this is like going backwards. When we did key features, I would have you guys write out the transformation, which is like how the graph changed compared to the parent graph. And so now you're going to go backwards. And you're going to write it in vertex form. So it says y equals x squared, that's the parent graph, shifts 4 units right, 2 units up, stretch by 6, and opens down. So you kind of have to remember, like, what do each of these do? So when it moves right, left, up, down, that's the vertex. So if you guys want, we can actually write out the A and the vertex. So 4 units right, 2 units up. So that would mean we have a vertex of 4, 2. And if it moves stretch by 6 and opens down, that's A. So stretch by 6 and opens down makes it negative. So there's our A and our vertex. So now we can write the equation. So y equals -6 x minus 4 squared plus 2. Oops, my bad. So that's number 11. And then number 12, it says y equals x squared, which is the parent graph, is compressed by 3/4. Compressed means that that's A. So if it says stretched or compressed, that's always just A. And it doesn't say that it's opening up or down. It doesn't say it's opening down. It doesn't say it's flipped or reflected, so that means it's going to stay positive. Then it says it shifts down 2 and left 4. So that part's talking about the vertex. And if it shifts down 2 and left 4. So you got to remember which one does what, right? So the first value of the vertex actually moved you left and right. So left 4. And then the second value is what moves you up and down, and it says down 2. So this one, they kind of told you the information backwards just to try to trick you when you did the vertex. But just remember that the first value always moves you left and right, and then the second one is what moves you up and down. So now I can write the equation. And it should look like that. So that's all the problems from the front side of the unit